Okay, continuing on why testing is necessary. Why? Again, this is the second part of the level 1, chapter 1 or part 1. So 1.2, why is testing necessary? Based on the foundation level ISTQB 2018. Why test is necessary? So people make mistake due to failability, but also due to pressure. So for example, attention to the details, the time constraint, lack of knowledge, experience, and any software, any program code is it's present everywhere these days. Everywhere, everything that you do. From banking to e-commerce to cars. Oh my God, these days cars is even much more programmed than used to be years ago, decades ago. Electrical appliances, you can order food from your fridge these days. Arms as well, heating systems, and many more. So the failure of the system can result on financial loss, waste of time, loss of reputation, or in worst case, injury and death. I mentioned these in the first slides. So the test helps reduce the risk and potentially identify the failure before it goes live. Expanding a little bit more about the no attention to detail. So the detail-oriented focus, which can be a weakness in some cases, such as when attention needed to be split up amongst various tasks or projects simultaneously. Sometimes you find yourself working in multiple things and multiple tasks and multiple projects, and then you won't have the appropriate time and to be able to concentrate and do it thorough and properly. Time constraint. This is the most, I guess, it's one of the most used word when we're testing. You don't have time. So where the insufficient time is available may lead to someone into taking an action that they wouldn't do otherwise. And if they given more time to do it. Lack of knowledge. Yeah, there will be circumstances and situations that you don't know. You simply don't know. You can't know everything. One of the things I like about software tests is like you constantly learning, and there's always new things, new interesting things, new things to learn. But you can't know everything, and that can definitely affect the end result, and you only realize afterwards when it goes live. Experience as well. More experience you get, obviously better you get at it. There are some situations where experience speaks up when you are helping solving a problem or a situation, and when you will have an approach for determinate situation that can affect the end result as well. Okay, so here are some an overview of the phases, typical phases on a big overview of testing. So there's the different phases that you've been involved and worked with. So there's the analysis phase, which is really important to have testers in there as well, as early as possible. If you have testers involved in the analysis phase, it can help when refining the user stories and reviewing the requirements. It can help prevent defects going into the requirements and into the development phase. It helps reduce the risk of something incorrect or untestable being developed. At the design phase as well, it's good to have testers involved at that phase, because while the system is being designed and being discussed, testers can help thinking about how am I going to test these, and also can help understanding and reduce the risk of things that's going to be designed before it's actually get designed. Again, asking the questions and they're just being curious and being intrigued about what is being designed. The code phase, having testers working close with developers while the code is under development can increase each other's understanding of the code and how to test it. This increases the understanding, and it can reduce the risk as well of defects going within the code and the tests as well. And then the release phase. So the release phase is important as well to be involved, because you can detect failures that might otherwise have been missed, and support the process of remove the defects, support the debugging, and these can increase the likelihood that the software meets the stakeholders' needs as well and satisfy the requirements. So the relationship between testing and quality assurance, this distinction, it's important, because I see out there as well in LinkedIn, and I see people talking about, or recruiters, if they are not experienced recruiting testers, this can get a bit misleading and confusing as well when I read the JDs, job descriptions. And I can kind of see sometimes there's a confusion about between these two. It is good for you to know the difference between them two, because we're following the ISTQB. The testers seek to uncover bugs before users come across them. So this is like the primary objective of a tester. One of the main tasks is find bugs or prevent bugs. And QA, the focus of quality assurance under the larger concept of quality management, which ties them together, is to work on constant improvement of the development process by working on the appropriate execution of the entire process. It contributes to the prevention of bugs to appear. So it's like the prevention side of it. But again, testers find bugs. Quality assurance, they help improve the process and help preventing the bug to appear. This is a really good one as well to think about. Just bear that in mind, this will follow in the ISTQB exam as well. Error, defect, and failure. Try to think in an order of sequence that things happens. Or always start from a human error. So human error. So associate error with human. So that's a good tip there. Humans, they could mistype something. So it could have a misunderstanding, or could have a lack of planning, or even capability as well. So that's a human error side of it. So the human make a mistake in the code, okay, then develop in the development of a document specification. And then a defect, it's a problem caused by the error. So it's derived from the error. So error first, and from the error you have a defect, okay? And what does that defect cause? It calls a fault, or equals a failure on the system, or component that can caused by the defect. So error, defect, fault. So that's the sequence. That if you remember that sequence, remember this little story, then you're good to go. You'll be okay with any questions around that. So that failure not only happens due to the defects, okay, that's another thing as well. So it's not only defects caused by an error on the human, okay? So it's not only humans that causes a system to fail. So there's that aspect, which is really important, but there's other things I have to think about as well, the environmental conditions. So let's say, a computer is made to run a certain temperature. So if it's too low or too hot, that could cause a hardware failure. We call it environmental failure. Or maybe there's a leak on the aircon system, and it maybe drips on top of a computer or a server. These days it's more of a cloud-based, but can you imagine like in a server room, and you have aircon, and then you have a leak, and then it drips water in the main server of the mainframe. And that's not caused by an error. That was caused by environmental condition, which led to cause a hardware problem. Okay, all defects start with human error. Not all defects. Well, all defects start with a human error, but not all failures start with human error. The tester job is just to expose the defect by causing a failure. So you deliberately go and try to cause failures on a system to expose the error. Okay, does that make sense? Before it goes to production. Again, this is the same thing, but it's just in a table, so you know the phases. So error and mistake is found by developers. They can overlap with testers as well if the testers get involved in the code. And the defect and bug fault can be, it is testers that find in the intermediate level of the system when the system is in test. But developers as well, they can kind of come across this as well while they are coding. The failure, which is the end result of the error or the bug, and when the full system is up and running and released. Again, like I said, I'll repeat myself many times about same thing, so in a different way, so it helps you imprint in your subconscious mind. So errors may occur for many reasons, such as time pressure, human fallibility, inexperienced or insufficient skilled project participants, miscommunication between project participants, including miscommunication about requirements and design, the complexity of the code, design, architecture, the underlying problem to be solved, and the technologies used, misunderstanding about intrasystem and intersystem interfaces, especially when such intersystem and intersystem interactions are large in numbers, and the new unfamiliar technologies. And this is a quote from the ISTQB Foundation Level 2018. Okay, just bear that in mind because this is important part as well that falls into the exam. This next slide talk about the root cause of a defect. In this foundation level, it doesn't expand in full detail about the root cause, but it is an important point to talk about. And like I said here, if there's a single word you can focus on here, is the root cause. That word, okay. A defect causes a failure, give the defects of the system not being worked as expected. In these syllables here, it doesn't fully cover. If you want to know more about it, it is under the more expert level of the ISTQB exams, so more of a test management or improving the test process, which is like 10 years experience or something. But in here I'll give you an overview about that. Okay, so I just put this drawing here just to kind of help explain about the root cause so you understand where that comes from. So let's say a product owner works with the business users, gather all the information, and work with the business analyst, write the documentation, get it ready for the user story. But from the beginning, they capture something that it's an error. Remember, human error, something more ambiguous or a misunderstanding, but he put it anyway without knowing, like without blaming both, but the product owner, the business analyst, and then they break it down into user stories. Within these user stories that are prepared for the developers and the testers to work from it, they write defective user story. They write the error in there. Okay, and then the developer and the tester start to prepare for testing, but the developer start to code that user story, a defective code, but he thinks it's fine because he's just following what is being written, okay? And that defective code gets into the system. The tester just tests against the acceptance criteria of the user story, okay? So yeah, he's testing fine because it's working as it was asked to be coded. So let's say hypothetically in this example, it's a calculation, okay? And then it does the improper calculation, but the tests are fine because it follows the user story. It finds its way to the production, to the users, and then the users complain. It says, well, incorrect interest payment, failure. So these are the effects of the root cause. Okay, as part of the completion report after everything's complete, lessons learned, and everybody gets together and discuss and says, well, what was the root cause of it? And then you go back to the beginning, you look for any lack of knowledge. Does it need to get trained in the topic of interest calculation? Did the interviews and the workshops wasn't appropriate? Try to improve these for future requirements gathering to reduce the risk of defects in future from the beginning. Don't wait until it goes all the way down to find it in the production. So the system worked, but it worked incorrectly as per the user's point of view. And that's how you relate the root cause of a system. Okay,